Now, you will see that we've got a big old chart to fill out. Okay, so let's make sure we get one last little bit of practice in together. Okay, we are going to take the first box. Oops, I'll go back. Okay, I'll go back, I promise. We're going to take this first box of your chart. We're going to use these numbers, and we're going to do this example together, step by step, and then we'll go through row by row and we'll be able to check your work. Okay, so I promised I would go back. Here we go. So you can see in your baseline normal rat, okay, the values that are provided to you, we're saying that your rat consumes 7.1 milliliters of oxygen in 1 minute. Okay. We need to convert that to usage by hours. Okay, so we're going to do our conversion really quick. Let's plot by our 60. In your chart, it says that the rat we're talking about, our baseline normal rat, weighs 244 grams. We need to move our decimal place over to convert to kilograms. Okay. Once we have our new value, okay, so once you convert your milliliters of oxygen per minute to oxygen per hour, that new number is A. Okay. Once you take your weight and convert your grams to your kilograms, okay, that's our new number B. Once you have number A and number B, go ahead and divide those two numbers. That will give you your metabolic rate, your BMR. That's going to be C. So pause the video real quick. Again, do the math yourself. Make sure you're understanding how to convert minutes to hours. Make sure you understand how to convert grams to kilograms. Make sure you know how to divide these numbers correctly. Okay. When you're ready, restart the video. Let's check your work. Okay, you've done your work by yourself. Let's check your answer real quick. Okay. So you should have been able to take 7.1 milliliters of oxygen in 1 minute. Okay. Multiply that by 60 minutes per hour. That gives us 426 milliliters per hour of oxygen. Our weight was 244 grams. We're going to move our decimal place 3 places to the left. This gives us 0.224 kilograms for our rat. Last but not least, if we divide our numbers, 426 divided by 0.244, this gives us a BMR of 1,746 milliliters of oxygen per kilogram per hour. If you look back to our values, this is within normal range. Okay. Now, just a side note, just for clarity and ease's sake, just go ahead and round up to the nearest whole number. Okay. With these numbers, you're very likely to get a decimal place. It could have been 1746.45321. We're just going to go ahead and round to the nearest whole number. Okay. Now, that filled in these boxes. Go ahead, pause your video, fill in these boxes. Okay. When you're ready, come back, let's check your work. Okay. Now that you've had an opportunity, let's come back, let's check your work, let's make sure you're on the right track. Okay. So we had just done this one. This is our final answer for our thyroidectomized rat. This is our new answer for our hypophysectomized rat. If you did not get these answers, okay, please go back, rewatch from the beginning, make sure you understand how to calculate these BMRs. Make sure you're understanding how to convert the milliliters per minute to milliliters per hour. Make sure you are understanding that you need to move your decimal place 3 places to the left to convert grams to kilograms. Okay? When you're ready, let's go to the next column, or excuse me, the next rows. Okay? Take a little bit of time, pause your video, work on these by yourself. When you're ready, let's check our answers. Okay, now that you've done all of your work, let's check your geniusness. If your answers do not match my answers, again, please make sure you're taking the time to go back and figure out how we're getting to these answers. Next row, pause your video, complete your math. When you're ready, come back and let's check your answers. Okay, you've done your math. Let's check your work. If your math matches my math, awesome. If your math does not match my math, again, take some time, figure it out, go back. Maybe you just accidentally punched something into the calculator wrong. It happens. But let's make sure we're doing this correctly. Okay. Last row. Pause your video, do your math. When you're ready, come back, check your work. All right, you've done your math. Let's check your work. Last time, if your numbers don't match my numbers, make sure you're taking the time to figure out why. Okay, we have our data. Now we're going to analyze it. So, you've got your chart. Let's see what our chart says. So one at a time. Which rat had the fastest metabolic rate? 2A, what happened to the BMR of the thyroidectomized rat as compared to the normal rat? 2B, 3A, 3B. Read through these. Pause your video, jot down your own answers, take a look at the data that you've come up with, go back, look at what we consider normal, below normal, above normal, all of the information that we've been learning. When you're ready, come back and let's check your answers. All right, here we go. Which rat had the fastest metabolic rate? That should be your normal rat. And that should make sense. We haven't done anything to the rat. What happened to the BMR of the thyroidectomized rat? It was lower than the BMR of the normal rat. If you do not have a thyroid, you are not cranking out thyroid hormone. It will lower your BMR. All right, explain why the BMR changed. We just did. You have no thyroid. You have no thyroid hormone. Okay, your BMR cannot be normal. It will be lower. What happened to the BMR of the hypophysiectomized? That's so hard to say, y'all. Hypophysiectomized rat as compared to the normal rat. Again, it was lower than normal. Why? Because now we don't have a pituitary. So instead of not releasing TH, if we have no pituitary, we're not releasing TSH. Okay, so your thyroid is not being stimulated to release thyroid hormone. So again, our BMR is lower. All right, our next set. Pause your video, work through these. When you're ready, let's go over them together. All right, here we go. Let's check your work. 4A, did the BMR of the rat drop below normal? Or BMR of the normal rat drop below normal, normalize, or increase above normal after it received TH? And explain. So it increased. So our perfectly normal rat was secreting perfectly normal levels of TH to start with. Our BMR was perfectly normal, and then we gave it more thyroid hormone. Hopefully it makes sense that extra thyroid hormone means extra BMR, increased BMR. So 5A, did the BMR of the thyroidectomized rat drop below normal, normalize, or increase above normal after it received thyroid hormone? And explain your results. We're going to normalize. Remember, we had removed the thyroid of this rat, so it was not secreting its own thyroid hormone, so BMR would be lower than normal to start with. And then we gave this rat thyroid hormone. So we are now compensating for the lack of thyroid hormone that it should have been getting in the first place, so our BMR went from below normal to normal. Now, 6A, did the BMR of the hypophycectomized rat drop below normal, normalize, or increase above normal after it received TH? Again, explain. So, same thing here. We're going to normalize. We're going to go from below normal up to normal for similar reasons. Okay, so this rat again has no pituitary gland, so we were not secreting TSH, so we were not stimulating the thyroid. Okay, no, if this thyroid is not being stimulated, it's not going to secrete thyroid hormone, so our BMR would be lower than normal. We're compensating for that by providing thyroid hormone to raise that BMR back up to normal. All right, here we go. 7AB, 8AB. Pause the video, do your work. Let's check your work. All right, let's check your answers. What happened to the BMR of the normal rat after it received TSH? Okay, it increased. Okay, why did it increase? Because now you have excess thyroid stimulating hormone. Okay, so our perfectly normal rat was making perfectly normal amounts of TSH. We were stimulating our thyroid like we were supposed to already. Our BMR was normal already. We have increased all of these things. Our BMR has now gone above normal. Okay, what happened to the BMR of the thyroidectomized rat after it received TSH? And explain. Well, it is lower than normal. Why is it still lower than normal? Okay, well, your thyroidectomized rat has no thyroid has no thyroid gland. So providing it with thyroid stimulating hormone, you still don't have a thyroid to stimulate. Okay, so your thyroid is still not going to be able to crank out thyroid hormone. Your BMR is still going to remain below normal. Okay, here we go. Next set. Pause your video, do your work. When you're ready to check, start your video again. All right, let's check your work. What happened to the BMR of the hypophycectomized rat after it received TSH? And explain. It normalizes. Okay, so your hypophycectomized rat has had his pituitary gland removed. So we were not secreting thyroid stimulating hormone. You have now compensated for that by adding TSH. So you are now stimulating your thyroid to release its own thyroid hormone. Now that we have thyroid hormone secretion, we have normalized our BMR. Do the results of the thyroidectomized rat indicate a hyper or a hypothyroidism disorder in this rat? Be a hypothyroidism. Okay, so your thyroidectomized rat still indicated below normal BMR levels. All right, here we go. Next set. Pause your video. Jot down your answers. When you're ready to check, restart your video. All right, here we go. Let's check your work. Did the BMR of the normal rat stay below normal? Did it go below normal after it received PTU? It went below normal. And explain. PTU is a thyroid hormone inhibitor. Okay. 12. Did the BMR of the thyroidectomized rat stay below normal, or did it go below normal after it received PTU? It still stayed below normal. Why? We still have no thyroid to inhibit in the first place. Okay, so we really didn't see any change there. Last set. Pause your video, do your work. When you're ready, start your video. We'll check your answers. All right, here we go. Let's check it. Okay. The BMR of the hypophycectomized rat stayed below normal. Why? Because PTU is still a thyroid hormone inhibitor. Okay. So anything that was working normally, PTU is still going to inhibit the thyroid hormone being excreted ultimately. Okay. Any of our rats that weren't even able to secrete thyroid hormone, okay, because they lacked a pituitary or they lacked a thyroid hormone, PTU is really not going to have an effect one way or another. Now, do you think the drug propylthiouracil, or PTU, is used to treat hyper or hypothyroidism? Be hyperthyroidism because it is a TH inhibitor. So if you have too much thyroid hormone, PTU might be an option to lower your levels back down to normal. All right, last topic. Okay, we're going to compare BMR to BMI. So your basal metabolic rate, we said that's how much energy you need just to stay alive every day. Everybody knows that we measure our energy consumption when we talk about food. We measure everything in calories. Now, when nutritionists refer to calories, so the numbers that you see on the boxes and the bags and the cans of food that you eat, those calories are technically kilocalories. So for every calorie, quote unquote, that we consume, it's technically 1 kilocalorie, and so it would be 1,000 calories. Okay, so that kind of gives you an idea of just how much energy your body actually needs every day. Okay, and again, when we talk about this metabolic rate, we're really only measuring the catabolic reactions, so the breaking down of the food, the nutrients, and things like that. Okay. So we do have things that can affect our BMR rate. Okay. What are those things? Well, we can increase our BMR by increasing our physical activity. So every time you exercise, you burn more energy than normal. If you increase your height, your stress, or if you have a fever, all of those would increase your BMR. Some of them temporarily, some of them more long-term. Decreased environmental temperature, so the colder you get, the more energy you need to keep yourself at that good old 98.6. Okay. We also have factors that will decrease your BMR, so as you get older, okay, if you put on weight, things like that, okay, you do not need as much energy to stay alive. Now your BMI, it's a pretty popular topic in society. Your body mass index really just uses a formula to calculate your quote-unquote BMI number. It's a relationship between your height and your weight. And you can see we have various categories for not only both male and female, but even age range. Okay, we can see that, you know, anything below 18.5 on the BMI is low, but if you're this age range, it's below 21, things like that. Okay, so take a look at this chart just real quick. Okay, and then think about your height, your weight. You can Google a BMI chart if you want to look it up. Okay, just to kind of give you an idea of how height and weight correlate with this BMI number. Now keep in mind that BMI might not be the best way to determine whether or not you're healthy. So for example, think of a bodybuilder. Okay, so bodybuilders, their weight is very high. It's all muscle, but technically their weight's very high. So if you looked at a BMI chart for a lot of bodybuilders, if you followed along, did their height, did their weight, and looked on the scale, you quite possibly could measure them as being very high or obese, morbidly obese, any of those keywords that don't sound very good. Okay, so you really kind of have to take into consideration the person as a whole when you look at their BMI values. Okay. All right, that concludes this lecture on BMR, BMI, our calculations, and anything else you need, send me an email.